In question 6 we have 4 identical 1.5 volt cells with negligible internal resistance. 2 are in a parallel pair, with the other 2 in series with this pair. We also have 3 4 ohm resistors, one on its own in series with a pair in parallel. In A part 1 we need to calculate the total resistance of the circuit. Well, for the resistors in parallel, 1 over the total resistance is equal to 1 over resistor 1 plus 1 over resistor 2. Both resistors are 4 ohms, so we can simplify to 2 over 4 ohms. Not forgetting to invert gives a resistance of 4 ohms over 2, which is 2 ohms. It's useful to remember that when we have a pair of identical resistors in parallel, the total resistance is half any one of the individual resistances. So the total resistance now is the individual 4 ohm resistor plus the 2 ohms of the parallel pair, giving 6 ohms. In part 2 we need to find the total EMF of the combined cells. Well, the parallel combination of AB will give an EMF of 1.5 volts, giving 3 1.5 volt supplies in series. The total EMF is 3 times 1.5 volts, or 4.5 volts. In part 3 we need to find the current passing through cell A. Well, for the circuit, current is potential difference over resistance. We've found we have a potential difference of 4.5 volts and a resistance of 6 ohms, giving a current around the circuit of 0.7 amps. Only half the current passes through cell A, giving 0.75 amps over 2, or 0.375 amps. In part 4 we need the charge passing through cell A in 5 minutes, given the correct unit. Well, charge is equal to current times time, and we've just found we have a current of 0.375 amps, and 5 minutes is 5 lots of 60 seconds, giving 113 coulombs. In B, we're told each cell can provide the same amount of energy before going flat, and we need to state and explain which 2 cells in the circuit would go flat first. Well, cells C and D will go flat before cells A and B. This is because each cell provides the same amount of energy to each coulomb of charge passing through, 1.5 joules for every coulomb, that's the 1.5 volts. Cells C and D have twice the current, and so twice the charge passing through per second, as cells A and B.